So today I'm gonna not talk so much about Perplex. I will use an example as an excuse to present you something else that we released yesterday, which is called AO Lite. So quite similar to what you presented, Tomo. So at some point we decided we needed to run a lot of tests for Perplex, and it was making us lose a lot of time to do everything manually. So at some point we decided to build our own, let's say, local version of AO. And yesterday we decided to open source it because we think it could be useful for everyone here. So maybe just to tell you what we are building. So we are building a decentralized exchange focusing mainly on perpetuals. So like Hyperliquid, you probably heard about this. And so we built an on-chain matching engine, on-chain liquidation engine. We also built decentralized market making. And I'm going to present you the last feature that we are working on, which allow you to create AI agents by prompting. And I think when you want to create a trading bot, let's say, the coding part, maybe just coding the bot itself is probably the easiest part. If it makes money, of course. But then you have to, like run it online, you have to maintain it, you have to do CI/CD and stuff, and it takes you much more time probably to do all of this than the simple strategy you are trying to implement. So the goal of this is to allow you to prompt a strategy, interact with the AI so that it generates the code. Finally, you can tweak the parameters. And later there will probably be a backtest so that you can backtest the strategy against historic data. So that after you just push the send button and it's going to upload it to Arweave. So the way it works is like this. When your strategy is ready, as a user, you can upload your strategy into your account. So like Bazaar, we create an account per user. And then the account will spawn a strategy process and initialize the code inside the strategy process. And then the user will not need to interact with the account or anything. It will be the strategy itself that will place orders on the market, and it will receive updates and act accordingly depending on the updates. And of course, a user will be able to spawn any number of strategies that can run in parallel. He will be able to stop them and kill them. And for that, in order to test it, we had some problems. So I think like everyone, we tried to run AO locally, and it took like too much time to test. And so we decided to create AO Lite. Which is, let's say, an emulator of AO. It just runs everything in Lua locally. So you can already use it. To use it, you just have to do like Rocks install AO Lite in your repo, and you can start playing with it. And basically, what you will have if you print the log, every time you create a process, it will add all its handler. Then you can create different kind of users. You can evaluate code inside of the process. You can like compare the state of the process to what you are expecting. And you can see all the logs of all the messages that are sent. So for example, here, we are minting some tokens. We are transferring them to someone. So we receive the debit notice, the credit notice, etc. The way it works is here. So you have let's say you have a script, and if in your script you have AO send, it will just unqueue the message. Each process will live in its own coroutine, and they interact with the normal AO messages. And you can or trigger the message sending manually with the scheduler, or you can have it return automatically, so that every time you send a message, it is automatically sent. You can spawn any number of processes you want. You can spawn them with some code, of course. And I think most of the you can assign messages as well. And so it looks like this in the code. So let's say you have this simple process you want to run. So in the process, of course, you have an AO.send and you have this handler. So you will use AO Lite to spawn it with on boot and with the data, which is the code you want. and you will spawn maybe another process with the same code, because here you are doing ping pong. And then you can simulate that process 2 is sending a ping message to process 1. And since it reacts to the ping, then the process 1 will reply to process 2. And you can see the logs here. So we created the handler for user 1 and for user 2. And then here we see that user 2 is sending the ping, which is here. And then we are indeed the code inside the process, which is replying with the code, with the pong. And now the demo. So for the demo, I prepared 2 strategies, like the thing we want to test. So a very simple TWAP strategy, so time-weighted average. So basically, let's say you want to buy Bitcoin, and you don't want to buy, like let's say you want to buy $1,000, but you don't want to buy it right now. You maybe want to buy it over a day. So you can prepare your strategy so that it will maybe do like chunks of data. Here we have 100 chunks, so it will do like 100 chunks of $10 to buy your $1,000, and you can tell the time interval, of course. And so here with Aeolite, we are initializing the strategy, and then we are sending the task to the bot. And since you have to trade against someone, we have to do another strategy, which is a stupid one. So basically, every time it receives a price update, it just places a limit order so that our TWAP can trade against someone, because you need someone inside of it, of course. So here to show you maybe is what it looks like. Yeah, so we have this file that uses Aeolite to spawn all the processes. So we have a market, we have like core, we have some pools, etc. So we spawn everything, we initialize everything, right? And then we have here the simulation we are interested in, where basically we have the code for our stupid maker and the code for the TWAP. We load the code in both processes. So that's the screenshot I showed you. And then we can run the simulation. And for the simulation, I coded just like a random price index that is like a Gaussian time series. And let's run it. So here you see all the messages are sent. So in like 1 second, yeah, we simulated, I think, maybe 1,000 events. And hopefully, we can also print the graph of what happened. Yes. So in blue, we have the simulated Bitcoin price here. So it's over a few hours, so over 2 hours actually. And in green, you can see all the buy orders that the TWAP strategy placed. And so our test kind of worked. So that's it for the presentation. And yeah, if you want to follow us, it's PerplexFi on Twitter. And of course, you can find in our repo the Aeolite library. So feel free to give us feedback. We released it yesterday, so the documentation is still a bit minimal. Thank you.